So yeah, so this is a simple project to show you how to build a serverless API that can call another API and spit information all the way back to the user. So I was asked to create this because we wanted an admin dashboard, which when you press a button, this button would then fire off a command and build a VM to a certain specification and then report back when it's done. So this is a very straightforward serverless API. So there's no infrastructure, there is no updates needed to be done on servers, nothing like that. It literally is pure code running in a serverless environment. So I'm going to use Visual Studio Community Edition, and if I bounce over to that now, here we are. User template. So you go to File, New Project, and you'll say Azure Functions. Then you'll get this option here. You give your project a name, a solution a name, and then you hit Create. And when you hit Create, what it will do, it will give you these options for the for Azure Functions. As you can see, there's quite a few of them. For this particular element, this particular project, which is going to be a HTTP triggered function, that's what I'm going to choose. So whenever it sees a HTTP request, it's then going to fire off some work. And as you can see, we're going to use a storage emulator and put the authorization as function level. We'll dig into authorization, all of that at some other point, but this is literally just to get the logic right and getting the app running so we can then ensure that we have something in place. So there we go. You'll pick HTTP trigger and then you hit create, and that will create your functions. So I'm gonna just close those ones. Now let's see. So let me just open up the project I had open. So I started work on one already. And that one is okay. So here we are. Here we have the boilerplate function. So when you first create this, this is what you get when you hit a template. You get given an initial function to get you started, and as you can see here, I've got it called function one, which is the name of the project or whatever it is you call it. This basic function, what it does, as you can see, you can fire a get or a post request to it, and then it would then do this logic here. And this is very simple logic. What it's saying effectively is once it starts, it's going to produce a log line saying, HTTP trigger function request. It's going to say, let's grab the query, the data that went into the request. So as it's either get or a post, it's going to take the query information, and that query information should be called name, or it will take the request body, either one. So if it's a get, you tend to put the query in the query string. So there'll be a question mark and then it'll be name equals whatever, and that will be the query line. Or if it's a request body, as in a post, it will be a package of information sent over in JSON. And if it's in the request body, you then have to do some work to it where you have to do some JSON deserialization. So you have to take the JSON data and strip out all the bits and make it usable data. Now, as you can see here, it then says, hey, it's doing a quick check to say where is the data? Is the data in the query string or is it in the post body? And whichever one has data in it, update that. Then we do a check here to say if there's no data at all. So if there's no post data and there's no get data, then this is what you do here. Put it into response message. Now, if response message, which is like checking the name part, if it's empty and there's no data at all, it's going to produce this line saying, give me some data. If not, it's going to go, hello, return your data back to you, and give you that function there. So very straightforward, showing you how to put data into it and then manipulate it and send data out. For this project, we need to do something a little bit more complicated. We need to be able to say, when this button is hit, I want you to then produce a set of data and send it to another API. So some of the bare bones of this is reusable. In this particular function down here, you'll see we have reused that top data. That's all pretty much the same. We don't actually need the request part, but I just left that in there. And I'm saying, okay, here we are, build all this data. I want you to log information saying create VM API triggered. Now I want you to build the actual place of what API we're calling. Then we move on to this part here where we build the information, the actual package of stuff needed. Now, to do that, that's following a format given by the API provider. So in this case, this is the Azure API, which we're saying, hey, how do you want me to communicate with you? What information should I provide for you to create me a VM? Now, in order to do that, we need to go and visit their API documentation, which I'm going to bring up now. So let's bring this up. So here we have this information. So it says in their API documentation, send it to this route, and here's the information I want to expect to see. So that's that route there, which we built in the that top line. Those top 3 or 4 lines will put that information together. And this body, request body, what I've done here, a good tip in doing this and doing this quickly to create the model for this information, copy that JSON, and then we can go to, there's loads of online free tools. In this case, I'm going to use this tool Slick. I'm going to paste in that JSON. I'm going to generate, and what this does here, it generates a bunch of C# classes, which I could then throw into Visual Studio, do some manipulation to make sure that it's right, because again, it's not always completely kosher. So you'll go through and you'll correct that that models, and then you have a workable model you can use to create your data. So let's go back to Visual Studio, and I can show you the model which I then created. So in Visual Studio, I then have this web server model, and you can see these parts here all relate back to the JSON from what Azure was expecting to see for this call. Now, I've given all things very clear names. Use JSON property to refer to the actual JSON name. So when it produces the JSON document that's sent over in the post request, they actually have all the right names there. And it allows me to also keep the conventions of writing classes and class variables in C#. So in C# you have to keep everything in capital letters as the correct way for these thingies within a class. So it enables me to build that element and to nest things correctly and have that all built up. With the model, which is key, with that model I can now choose to populate it with data in this function here. So as you can see, I've created a new web server model from here. So this is all called, if I scroll right to the top here, this is all a web server model. From here within the web server model, I've now created all the parts in there, and I filled in the data. Now that data I can actually fill in from, I have the options now, because now I've put it into here. I can either say at some point I can modify this request body here. So the user on the dashboard, if I want to ever extend it, the user can then have fields they can put in to change key names or key whatevers, so they can update that as it goes in. Or I can hardwire it, or I can put it into an app config file. I can do whatever I want to have this data modified. And that's the beauty of having that model there, because then you can apply that and address it in many ways. You can see those lines here that this builds the API request route, which is just all over here. And over here is me building the model and I'm filling in some data. Now I just put in the stock answers, I didn't fill in half of it, so this will not work when it actually sends off. But all the information is there, it's built all the parts of that. Now what then happens is you have to then convert this model into JSON data. And that's why I've taken this full-on object, the web server object, I've serialized it in JSON. I have then converted it to a proper application/JSON, so it's got the text elements to it, created a web client, and then done a put request to the client URL, which you saw me built earlier, and the data, and then I wait for the response on that, and that's it. Next stage, let's run this and see if it actually works. So I am going to hit the button, hit Azure Builds, and I'm going to bring up on this screen. Let's see if this all works. Let's take this one off. As we can see it building, make sure there's no crazy errors, nothing's going to stop. It's all looking good on that side. Yeah, let's bring up our Azure Functions emulation tool. So this emulator emulates what's happening in Azure, and I'm going to bring up Postman. Anyone who's doing any web work will know about Postman. Postman is a free tool that just lets you do a bunch of requests here and there. If you're not using this, you're gonna have to use something like curl, which is a small pain um, when you have something like Postman. So here this one is, and here's the output. So we can see the Azure Function Emulator has told us our address. Function 1, which was that boilerplate one, I'm going to grab that first and show you how this works. Let's just grab that properly again, highlight that. Okay, let's copy that with a right click, and let's go over to Postman. So with Postman, what you'll do, you will, let's just create a new tab. You'll pop the information in, and we'll say we want to do a get. And if I just do that and do a get on that, you'll see that our Azure function has done all the stuff it said it was going to do. It's created the log line, HTTPS triggered, function with request, and look what it's given back to me. This has to be triggered function execute successfully, pass a name to it. So for a get, we had it on the query string. Look at that. And to show you, name equals around. There we are. And that's the parameter it wants. If I do that now, we should see the other message come through. Ugh, it looks like it might be a bit stuck. Never worry. So what I'm going to do, I'm going to grab the other function, which is the one which we really want to test. This one here. I'm going to copy that one. Ooh, there it goes. Better late than never. So as you can see there, it's run it properly, it's taken the data in, it's reproduced that out in that area there. Now if I put in this one, which is the function I just created, and then I send that through, same thing, you see it's triggered it. Now because the actual query was full of junk data, you can see that how it's actually said, hey, this part here is what I'm looking for, status code 404 not found. So the actual API link I was sending it onwards to, because it was a junk one, it has come back and said it can't find it. So it works in effect. If I put in the right details, it would have went through, it would have produced that element and returned me either the correct status code of a 200 or 201. And that there is how quickly it is to create a function, a serverless API on Azure Functions, and you can create loads of these and be offline. So if I just get rid of that Postman screen, this is something that again you can do in about 30-40 minutes, and depending on how complex your actual API is, you can do quite a lot in a very short period of time. And again, when it comes to actually building this and then having it working, it is it's a great way to quickly extend information, pull data in. You could then call other parts of the Azure functions where you're actually writing data into storage tables. So the storage table function on Azure on Azure Storage is a mass NoSQL data store. So you could build a function that could data scrape a range of things, dump data into the storage table. You could then do analysis on it. You can have your own API wrapped around that sort of stuff, and you can really extend your applications you have. So this is a function which is really quick and dirty, and there it is. I'm probably going to use some of these in some of the products I have already, building some of these Azure functions in there, because that way it enables me to have a quick, scalable, cloud-based application with less overheads, as I'm only paying per the requests that happen, rather than having a server running that can accept multiple requests in as we go along. And with that, then at that level, I can then attach onto it my Azure repo or my GitHub or any other code repo, and then I have my DevOps pipeline and publishing things directly to those changes, which is the way how programming is. So there we are. That is creating a serverless API using